Good morning again. For the second session, we are going to study about science and evolution theory. One second, I think I should go to the slides. Slideshow. Beginning.
Yeah.
Okay. Science and evolution theory. For the past thousands of years, man wondered how living creatures came into existence. The general belief was that a god must have created life. However, some thinkers observed nature keenly and came to the hypothesis that life evolved spontaneously from inanimate matter due to natural processes like chemical and electrical reactions. They called this evolution theory. In this presentation, we will examine what the theory of evolution teaches, using scientific methodology that is recognized as a widely accepted scientific way of study. In the next presentation, that is next week, we'll study using the same scientific methodology, the alternative explanation that has been held for over thousands of years, that a super intelligent God had made everything, including life, by design. So let's begin the scientific methodology. So we are expected to define the question what we're going to study. Did life begin spontaneously by natural causes as theory of evolution teaches? So we have defined the question. Now let's go to gathering information and resources. So the first information that we want to gather is we want to find out the differences between living and non-living things. I think that is the basic thing to understand what is life. We should know what is a living thing, how does it differ from non-living. Then we'll study about the cells, the building blocks of organisms. Only cells will give us an idea of what happens in a living cell. Then we'll study how scientists explain life by mathematical analysis. And then we'll see the theory of evolution as taught in the universities. And then we'll gather evidences for evolution. Once we gather them, we'll analyze and critique the methods, arguments, and evidences put forth. And after that, we'll draw conclusions. That is the normal flow of this method, but what we'll do in our topic today is we'll do it a little different in order to save time. As we go through all those collection of data and what is taught in universities, etc., we'll start analyzing and critiquing right when you do that, because that way we can save time. And so let's proceed now. So how do living organisms differ from the non-living matter? One thing is voluntary movement. They move wherever they want to. Unlike things that move according to the force, for example, the frogs or leaves moving in a river, the leaves, because they don't have life, or any shaft that's floating on a river, it will move in the direction where the water takes it, where the force of the water takes it. Whereas a frog can move in whatever direction it likes. It can move with the current, or it can move against the current, or it can move across the current. It's voluntary. And all living organisms depend on energy. They need energy to live. Starting from a little germ to the biggest animal that you know of. They all depend on energy, so they all eat. Most of the day, all living things are busy trying to find energy, and they try to find food. Third one, they all require water and air. To save time, I'll be just reading these topics. I will not be explaining in detail because I have dealt that in the book in a more detailed form, running from 1 or 2 paragraphs to whole pages. But you are all I think aware of these things, so I'll be just reading them quickly. And all run on electricity, tiny currents, and all living things grow, they reproduce. All living organisms are highly complex, but they're perfect the way they are. And every living organism has multiplicity of components, yet they all work in unison. And when they reproduce, there is infallibility of reproducing exact same species. They do not produce any other species than their own species. Then sex, a unique component in reproduction, the universal concept of male and female. Though there are cases where reproduction has taken place, does take place asexually, but by and large, this is one technique nature has there, where reproduction takes place only when 2 sexes contribute and mate and reproduce children. Then self-preservation and striving to live for eternity. Fighting decay, fight against second law of thermodynamics. We're always decaying, so every moment our cells, they try to fight decay. Our cells keep dying, and then we start regenerating or always creating new cells to replace the dying cells. Then we have, all living things have instinct, they have senses, they have emotions, depending on, even an ant has an emotion. It can get angry, it can harm you. They have intelligence, decision making, judgment, symbiosis, that is cooperation among themselves, ethics, sense of beauty, entertainment and fun, extreme variety, and they make sound or music and enjoy them. They use camouflage, deceit and mimicry. They have wits, they battle. I've seen a program lasting about 4 hours on a documentary on television where several scientists throughout the world, they were trying to create a vaccine for AIDS, and each time they think they found a good vaccine, within a short time these AIDS virus started developing resistance to that and producing a new variety for which the vaccine did not work. So it looked like a battle of which the virus seemed to have mind of its own, and it was fighting against these hundreds of PhDs working on that vaccine. Then development without research. And no recalls. When you find all these fossils, they have not found any defective fossils, defective creatures. They were all perfect for whatever they were. If you take the ants from the amber, they say it's 50,000 year old, 1 million year old, but they're plain, they're exactly like our living ants or mosquitoes, except probably they're bigger. And then you have adaptability, and some higher animals, they use innovation and they make things. And more importantly, all of them have DNA, and all of them die. There's death. Living things die. Non-living things cannot die. I mean, because they don't have any life. Okay, so every living thing must have, as we know, they have these properties, and it is common sense that they should have at least 70% of these properties for any living organism to continue to live. It has to reproduce. If it didn't have the ability to reproduce, what's the use? It dies, and that's the end of it. Or right in the beginning, it should have a system for absorbing energy, creating energy. If it cannot convert energy to its nutrition, nothing can live. And that will be the end of the living organism. So all these capabilities, all these properties must be present in a living cell if it has to live for, if it has to reproduce and keep its species growing. So in our list, checklist, we have covered differences between living and non-living. Now let's go to cells, the building blocks of organism. Cells, the building blocks of organisms. Cells are the main building blocks by which any living organism, from the tiniest monocellular bacterium to the largest of the whales or dinosaurs, are built. Cells are very tiny, some 10 microns to 20 microns in size. You can accommodate 200,000 big cells to 800,000 small cells placed side by side on a 1 cent coin, a penny. So you can understand how very tiny are these cells, living cells of organisms. But if you see under a microscope, a powerful microscope, and you dissect it and see, this is what you'll find. This is the human cell, and you can see a lot of components inside. I counted about 14 of them. They have different names. So that's how it is constructed. And right in the center, you have what they call nucleolus. And inside that nucleolus, you have this DNA, the most important molecule of life. The tiny cell has about 80% of water, and the rest 20% is made up of around 14 components, including DNA in the shape of a double helix right in the center. And the DNA is made up of 3 billion pairs of strands occupying just 6 microns of space in the nucleolus of each cell. DNA has about 46 chromosomes, each containing hundreds to thousands of genes that have instructions to build various proteins. The DNA is found to be actually a sophisticated computer program that controls all the activities of the organism. That's what they found recently. You may say, well, human cell is a highly developed, in the chain of evolution, that's at least 4 billion years old. So what about the 2 billion year old cell, a primitive cell? If you call a plant cell a primitive cell, because according to the theory of evolution, the original cell was plant life, and then came the insects and mammals and human being. So let us see how the plant cell looks like. Actually, plant cell is equally complex as human cell. It has almost all those parts inside it, almost all, but some may be different. It has chloroplast, you see on the left, top left, and a few other things which we do not have. Now I'm placing them side by side, the plant cell and the human cell. You can see that they're almost equally complex. So the cell cannot live without all those parts in it. It cannot reproduce, it cannot build, manufacture other parts, and so proteins and all that, and so a thing cannot grow beyond that. So unless it has all those parts, we see that cell is a very complex and important building block. Now, how scientists explain life by mathematical analysis? Now, we'll be studying what Erwin Schrödinger said about it. What is life? Explanation by scientists. Erwin Schrödinger was a bright microphysicist or particle physicist who won Nobel Prize for Physics in 1933 for finding wave equation for electrons and contributed to the quantum physics. He was a strong atheist and believed life evolved spontaneously due to natural laws of physics without any supernatural or special creation by any god. He believed physics had an answer. He wrote a book, What is Life?, in which he attempts to prove how physics can explain how life evolved. Schrödinger's book, What is Life?, was the Bible for all evolutionists till recently. The present set of evolutionists shun his book because he not only failed to prove evolution by physics, but concluded his book saying that physics cannot explain all the complexities of life, with a fervent hope that future developments in physics may finally explain what life is. He then drifts off into Eastern philosophy, talking about Atma and Paramatma, or the soul and the divine spirit, and finally he talks about soul being part of divine spirit, so every soul is divine. That means we are all gods. It was so confusing what he was talking at the end, and many evolutionists now these days they don't even mention him. The present knowledge in all sciences has not been able to explain what life is and what conscience is, what mind is, and several other aspects of life. Believe me, he wrote that book in 1944, I believe. So it has been more than 100 years. And every scientist has been trying all he can to explain life through mathematics. use of mathematics, but nobody has been able to prove it. So we have seen all those topics. The next topic is the theory of evolution as taught in the universities. We'll use Evolution 101, which from soup to cells, the origin of life, posted on the internet by Berkeley University for our study. It acknowledges right at the outset that even ancient bacteria are enormously complex. It states that complexity did not develop all at once, but almost definitely developed in stages of long periods of time. The term almost definitely suggesting there is ample evidence for it. It outlines 5 major steps in evolution. So the 5 steps of evolution. Step 1, formation of simple organic molecules like nucleotides. 2, evolution of self-replicating molecules by natural selection and development of RNA, and then RNA dominated world for about 2 billion years. Step 3 is evolution of cell membrane. Step 4, evolution of modern metabolic processes. And step 5, evolving of multicellular organisms. And I have tried to put all these 5 steps in form of a graph, a chart. You see on the left extreme where the star is the Big Bang 14 billion years ago. It continued for several billion years, and about 4.8 billion years ago, birth of sun and planets, they started forming 4.8 billion years ago. And this is all according to the theory of evolution and theory of what the Big Bang and so on. That may not be what I believe, but I'm just showing you what theory of evolution teaches. And at about 3.8 billion years ago, step 1 started, that is birth of nucleotides, which are molecules, formation of molecules by chance. And then after many hundred millions of years, replication of nucleotides by natural selection. All these molecules were forming, and after several millions of years, they started replicating, producing their copies. Then step 2, birth of RNA. And then RNA dominates for a long time. Then you have the birth of DNA. And then DNA dominates RNA. And step 3 is birth of cell membrane, somewhere close to about 3 billion years ago. And step 4 takes place about 2 billion years ago, which is birth of single-celled organism. And then after many millions of years, step 5 takes place, that is birth of multicellular organisms. That would have been probably 1 billion years ago. And then from that multicellular organisms came the insects, and they evolved into mammals and reptiles and birds and so on, dinosaurs, and then into apes, and finally into man about the modern man about 50,000 to 80,000 years ago. So that's what they say. As I said, plant cell is not a simple cell, it's very complex. All the components in this plant will not survive unless it has protection by a membrane. If they're all, if you actually go to the functions of each cell, you'll easily understand that they cannot independently survive unless they're all protected by a cell. And these components are not very simple. I just Googled, I thought maybe these are not very important things. Probably the cell can survive without these parts. And so I Googled at random. I just chose on the right bottom, you had a Golgi apparatus. I thought it's funny, so I thought, let me Google and see. And as soon as I pressed the key, about 12 books showed up on the page on Golgi apparatus. And the cost, they said, is about $68 to $194 each. So they're very important. Doctors, they study each of these components to find out the causes of diseases. If any one of them is defective, that leads to disease, and that's why the doctors studied in detail every little component of a cell and wrote several books, and that's how they're trying to diagnose various diseases and finding solutions. So when they said, according to their statement, 3 billion years ago, or almost a billion years after the first nucleotide molecule was born, it was then that the cell started, the cell membrane started forming. And that is really ridiculous. Let's see, step one. When did that happen? Before 4 billion years ago. They may have been synthesized due to lightning hitting the primordial soup of several minerals and water. So what I highlighted boldly is what the course, that book is saying. They're using terms like it may have been synthesized. Earlier they said almost certainly, but now they're showing words, doubtful words like may have been synthesized and so on. And then they say RNA and DNA are long chains of simple nucleotides. But according to the present knowledge, they're very complex molecules. So I have a question. Question one, is it possible for nucleotides to form naturally? And my answer would be yes. Many complex molecules are formed in nature when two or more different molecules come together if they're chemically compatible, especially if you apply heat or electricity, and both physical, that means physics, and mathematical equilibrium is met. Examples are various salts, sugars, minerals, etc. And also minerals from crystals form crystals by arranging themselves in a lattice pattern based on their physical properties. Even drops of water, the planets, and the suns are examples of crystals. Nucleotides are complex molecules found to be carrying out a lot of functions like carrying chemical energy between various parts of the cell and also in forming RNA and DNA molecules. So they are important, they are very complicated molecules, but nucleotides are non-living, or they are inanimate molecules. We can't say they are life material or living material. Step 2, evolution of self-replicating molecules, the RNA and natural selection. When did that happen? Several millions years after nucleotides formed. So I have a question. Question 2, we know RNA, which has the ability of replication, is formed of nucleotides. That's true. Is it possible for the inanimate nucleotides that are formed naturally to spontaneously develop the capability of replication? Will waiting for some millions of years do the trick? My answer would be no. Replication, as described in theory of evolution, requires a mind, a desire, and a sophisticated method to happen. All we know is everything decays with time. Our second law of thermodynamics, not gain newer and improvised abilities. They say all that happened because of what they call natural selection. So what is natural selection? According to theory of evolution, natural selection is a phenomena that nature selects and retains certain molecules beneficial for future evolution and discards those that are not beneficial. This answer suggests nature has cognizance or a conscience, a mind of its own, and has the foreknowledge to judge what is going to be useful several million years in future, and thus select the molecular features that are useful. What we see in nature, I believe, is natural formations, not natural selection. We see a lot of variations occur within species. It is wrongly termed as microevolution. The correct term would be adaptability. Latest knowledge of DNA suggests DNA has genes for all variations already embedded in it, with switches that can prevent or express them as needed. Example is a gene responsible for melanin. For example, the melanin is a molecule, a pigment molecule that rises to the top of your skin to protect your skin from the harmful effects of ultraviolet rays. And people living in tropical areas, people like me with brown and dark brown, black skins, they see a lot of sun. So it's a mechanism triggered by the DNA for those melanin molecules, which we can equate them to small little umbrellas rising to the top of your skin to protect your inner cells from damage. And people who live in the real cold parts of the world, like in Scandinavia and Poland, their skins are milky white because they don't see so much of sun. So their DNA has not released those functions. But if they come down to the tropical area and live for some time, the DNA would certainly release those switches, and then all this melanin can be expressed in their skin too. Now, natural formation. Natural formation forms because of the natural forces, the physical forces like gravity and surface tension and things like that. If it's a liquid, you'll always find them in spherical shape, like a water drop, or the sun, the planets, because they're all, at one time, they say they were fluids. Some of them are still fluids, they're gas balls. And so all the shapes of the planets and the sun that we see are spherical. And the same physical laws, they affect the formation of snowflakes. It comes in different millions of shapes. It's all dictated by physical forces. Same with the crystal of a diamond or any other crystal. They're formed according to physical properties, physical forces, how they can stack each one together, stack each molecule together. And so that is natural formation. According to Big Bang, planets and sun have been in existence for at least 300 million years before the first nucleotides began to appear and replicate themselves. They say by natural selection. If natural selection is a real entity with its own mind and knowledge and thinking and so on, capabilities, then my question would be, why did sun and planets, which were much older than nucleotides, why didn't they replicate themselves by natural selection? I think that's a smart question to ask. And the answer would be, because natural selection caused neither the nucleotides to replicate nor the sun or planets to replicate. The idea of natural selection is absurd and dead wrong. At step 2, the terms of expression in the beginning, that they used in the beginning, almost certainly changes slowly into terms like probably and would have and so on. So these proponents of evolution theory, they talk as if something has certainly happened, but then when you start asking them questions, then they slowly mellow down into very doubtful expressions. For either of the developments to take place in molecules, a thinking mind, a purpose, a desire, a carefully planned design is required, not an accident. So they say it all happened by accident. Let us see what another atheist scientist says. The appearance of such a molecule, given the way chemistry functions, is incredibly improbable. It would be a once in a universe long shot, said Robert Shapiro, a chemist at New York University. He's an atheist. He says, to adopt this view, you have to believe we were incredibly lucky. In my opinion, I would say it is like kicking a soccer ball towards the goal, but it lands accidentally on the moon. Not a logical and convincing story. Do you think? It's impossible mathematically and physically. So, going back to the 5 steps, we have seen both the steps, step 1 and 2, and the next step is evolution of cell membrane. We talked a little bit about it. As I said, none of these components that forms the cell can survive without protection of a cell membrane. So they must have been there right from the beginning. All of them would have occurred, come into existence at the same time, not in stages over millions of years. Questions on steps 1, 2, and 3. I have these questions on the handout that we gave in order to save time. I'm not going to read them, but we'll proceed to the next step. Evolution of modern metabolic processes. step 4, they said development of unicellular organism 4 billion years ago. I think it should have been 2 billion years ago. And then the step 5 is development of multicellular organisms 2 billion years ago, proceeding to development of reptiles, birds, dinosaurs, mammals, apes, I don't know how you spell it, neanderthals, and the modern man 5,000 to 50,000 to 80,000 years ago. Even unicellular organisms is unbelievably complex, belying the simplicity portrayed by the evolution theory. Having gone through the questions on step 1, 2, and 3, the believers in evolution theory split into 2 groups. Group 1 would lose their belief and lose interest in steps 4 and 5 anymore. Whereas group 2 still hope someday some tangible proof can produce for all the steps 1 to 5, and they hang on to their belief. I would like to say the group 2 people are the admirable out-of-the-box thinkers. They are honest and sincere and honorable individuals. They continue with their research to find tangible proof for evolution, and in the process discover more wonderful facts about cells, how diseases are caused and how they can be treated, and find some good treatment solutions for the dreadful diseases like cancer. They may probably never find a proof for evolution because of the millions or billions of years needed for their experiments to replicate the evolution processes. Both the evolutionists and the non-evolutionists finally come to similar conclusions. The evolutionist saying we are fearfully and wonderfully evolved, while the non-evolutionist saying we are fearfully and wonderfully made or designed. So we have covered all the 5 steps. So in the scientific methodology, we also have to examine the evidences for evolution, what the evolutionists have put forward for us. And so we, for the sake of time, saying that I don't have time, we have already analyzed and criticized the methods, arguments, and things put forth in all the 5 steps. And let's see what the evidences of evolution is. My search on internet does not yield much results. People, though it's formally claimed that there are about thousands of evidences for evolution, I selected for review the following 5 major evidences that are commonly presented. What are they? Ancient organism remains, fossil layers, similarities among organisms alive today, similarities in DNA, and similarities of embryos. And I think they added a 6th one too, called artificial selection and breeding. They say they are all evidences for evolution. For lack of time, let us wrap up. I have very extensive details in the book that I'm writing. I hope once it is published, you'll be able to read them. But talking about evidences, most of these evidences deal with the similarities between the ancient creatures found in the form of fossils and the creatures living today. A lot of similarities and some variations are found and provide inalienable proofs of evolution to the evolutionist. These proofs can readily be accepted by all of us, provided there are no other explanations possible for these similarities. One explanation that I can give, what if the designer chose, I believe in design, so I'm saying from my perspective, what if the designer chose the same basic functional structure for all these species, because the structure is basic and efficient and nothing wrong with it? For example, the same engine can be put in an automobile that runs on the road, or a speedboat that runs on water. So the speedboat and the car are two different species. But when you open them, you'll see the same engine, but the propellers are modified. A little variation in the transmission. And just for information, the topics covered in the rest of chapter 2 and science and evolution that I am not dealing right now, but which are in the book. Here are the portions. So far I've covered only half the chapter. So in the rest of the chapter you have three, the book deals in great detail each of the above evidences that they have mentioned. It deals with subjects like understanding sedimentary rocks, understanding fossils and fossilization, determining ages of fossils and flaws in both carbon dating and radiometric dating methods. Then distinction between adaptation to environment and evolution. What we understand as adaptation to environment, the ability to adapt to an environment, is falsely called evolution. I also deal with theistic evolution. Then I deal with genetic engineering and human genome project, etc. So what conclusions do we draw? That's the printout, the synopsis. And so because of lack of time, please read the synopsis that is distributed to your hands. Thank you.